Thank you. So hello, it's a pleasure seeing you all here today. So the main topic is DOH, or DNS over HTTPS. So my name is Raimonds. I'm a technical expert iPro, so my main domains of competencies are SIEM solutions, privilege access management, and also vulnerability lifecycle management. I also like to research security and to promote security in a broader view. So I would also like to give out a great shout out to Lynn Clark. I will be using her code cartoons to better demonstrate the solution and how it works. You can check her out at Twitter or at the website codecartoons.com. So in today's agenda, we will be looking at the basic concept, how the internet works. So about the web part and also the DNS part. And we will be looking at the problems, so what's wrong with the current model. And we will also be looking at how to solve these problems with the trusted recursive resolver project and the DNS over HTTPS. So has anyone here today accessed a website or a mobile application? If you have, please raise your hand. So most of us has, and as we saw in the morning's introduction, internet is everywhere, and basically a Cambridge University research has shown that if we have exposure to either mobile or a laptop, 96% of us use this every day. So that is a huge amount of us actually using internet. So in simple terms, how HTTP works, so our browser sends a HTTP request, a GET request to a web server, and we get back a file, HTML file, which contains the contents of the website we want to visit. Well, this is all nice and simple, but in the real world, of course, this isn't that simple. So we have multiple steps in the middle, multiple routers, which are on the path to our web server. And this, of course, introduces some problems. I will use a simple illustration of a school desk. So there's a node being passed from left to right. So there's a node being passed to Sandy, and there are two people in the middle. So the node can contain some sensitive information or whatever, and the people in the middle can view it. Since it is plain text, they can read the contents, and they can further tell it. So one of the variants is that there is something juicy. For example, some information like, I don't know, vote for Hillary, or vote for the specific party, and the rest of the classroom will know about it, and they can use this information against you to influence you to make some decisions, or just sell it to someone who wants it more. And of course, the message can also be tampered with. So a message coming from the left to right, so vote for Hillary, can actually be changed to vote for Trump for some reason. And the person on the other end will receive the message and think, oh, you're voting for Trump, I will vote for him as well. And so by modifying this data, you can also inflict some harm on the public domain. So obviously this is solved. So it was HTTP, Hypertext Transfer Protocol. Right now we're on Hypertext Transfer Protocol Secure, so HTTPS. So that would mean that the contents that we're visiting, the website, is put in an envelope, and there is a lock put on it. So on the both sides, only the sender and the receiver can read it. So obviously, there are some issues with the encryption algorithms. For example, the SSL was the first, and there was TLS 1.0, 1.1, 1.2, and right now we're looking forward to TLS 1.3. But this is a more secure reality that we're looking towards on the web space. Well, obviously, HTTP is a big part, but then there's also the DNS part. So DNS is more than 35 years ago, so it's a very, very old protocol. it was built in a time when security wasn't really the main concern. It was more about getting things going, getting things started. So basically what DNS does, it makes this very hard, the IP address 208.80.154.224 to resolve in wikipedia.org. So we can use our more catchy name for our website to resolve to a specific web server's IP address so we can receive the content. So the domain name is split into 3 parts. So there's subdomain, second-level domain, and top-level domain. And each of them is resolved to the specific entity at the very end. And obviously, all this communication currently is happening in plain text. So everyone can see where you are going, what you are doing, and so on. But how do we know to which server to ask for the specific request? So you need a resolver. And how do you get this? Well, most of our computers are by default configured with a specific setting that we are either unwilling to change or lazy, or the ISP provides us with a specific DNS server which they recommend that is the best, and so we use that. So those are the 2 main concepts how the internet works. So we use the HTTP to get the data, the contents of the website, and before that we use DNS to resolve where the web server is located at. So, and we come down to the 2 big pillars. So one is privacy and one is security. And as we have seen in the past, for example, also with the American election, so there was this ton of information gathered from Facebook, from the public space about users, which was used to influence and manipulate elections. So information about our behavior, our actions, is a very valuable information, and people are looking forward to getting that. And obviously, security is also very important. As with privacy, we like to seal our windows in night or at the evening when it's better to see through. Also with security, where we like to lock our doors in our buildings. We like to lock our cars. We don't keep them open so that anyone can access them and take what they want from them. So this is also a very important pillar. So in privacy part, it all comes down to how much money are you willing to spend to see what somebody has been looking at. So it can be your, I don't know, wife. So it can be your neighbor, or perhaps you just want to see what our country's president is doing currently. And depending on the status of the person, the more valuable the information gets. And obviously, in the security part, you can just modify the message that's coming in, and you can send it to your web server that you control. You can take the credentials of the portal you're trying to access. For example, it could be an internet bank. Obviously, they have more security in place, but that's a simple example, or Facebook, or your corporate email, from which after that you can send phishing emails, and so on. So in the broader view, so where does this problem come from? So obviously, there's the resolver, which we can see on the right. So that's the first part. They can read the information you're transmitting. They can also tamper with it if they want to. So then there are these on-path routers. So a lot of routers, when you're visiting a website or accessing a DNS server, your information goes through many, many routers, many ISPs. So it can be Latvian ISPs, Polish ISPs, German ISPs, and so on, till you get to your destination. And all of them can read your information. They can read your DNS query. They can also modify it if they want to. So they know where it's coming from, and they can change it. And of course, the DNS server at the end, which can read the messages, and they don't really want to modify because that would influence the service as itself. So how do we solve this? So there is a trusted recursive resolver project which is pushed by Firefox in cooperation with Cloudflare. So the idea is to create a trusted resolver for everyone to use. So a resolver, DNS resolver, that will keep the data for 24 hours and not longer. Obviously, you need to keep some data in order for the performance to be good. And also a resolver that is being audited by a third party to make sure they're not using this data or selling it. And obviously, Google also has implemented their own DNS over HTTPS solution, which is a little bit different, but it also has the same principles. But I'm not so sure about their resolver. What are they using it for? So I wouldn't probably recommend using Google, but if you want to, of course, you can always do that. So what is DNS over HTTPS? So basically what the name states is just a DNS query, as we saw before in the illustrations, being sent over the HTTPS channel. So it's an encrypted envelope that's being sent with our query instead of the plain text that we're currently using to receive where do we have to go to get the contents for our web page. Well, obviously, this is a very cool thing to have encrypted DNS to hide our privacy and have greater security. But what about performance? So we need performance as well, obviously. So what Mozilla did, they introduced this project in their Firefox nightly build. So the idea was that they will send an unencrypted DNS request to your default resolver that you have configured, and on the other side, they will send an encrypted request to the Cloudflare resolver, and they will measure the response. So 25,000 users participated, and this is the graph that they came up with. So basically what the graph shows is that on the fast queries, regular DNS is faster. So it's about 6 milliseconds faster, but it's a price you have to pay for privacy and security, obviously, and it's not really that much of a difference in your browsing experience. But what was interesting, when the regular DNS took longer to respond, DNS over HTTPS actually responded much quicker. So that's an interesting concept that they came up with. So, well, yeah, cool. So I want to participate. So what you can do, you can just download Mozilla Nightly, go to your address bar, type in about.config. So you can search for network.trr, and then you can set the network.trr mode to 2. What this will do, so in the first step, the browser will try to send the request to DOH server, so DNS over HTTPS, so an encrypted packet. In case it fails for some reason, it will just use your regular resolver. So you don't have any user experience impact on that. And if you want to go really hardcore, you can just put on mode 3 and just go full DNS over HTTPS. Obviously, we also need to provide the URI for this. So Cloudflare has a resolver, Google has a resolver, I think Facebook also had one experimental, and there are many other resolvers coming out, so you can just Google that and check for the information about the resolvers. And you can obviously also set one up on your own. So the code is available. And so why actually you would use DNS over HTTPS? So it uses this port 443, which is mostly permitted in all firewall environments, outbound, of course. And the interface and the developing part that you need to make is a HTTP based, so it's very developer friendly. It's not really very complicated to set up, and so on. So why should you be excited? Well, obviously, this is a cool thing. Encryption is always cool, and you need to stay private and secure in your environment. And I'm not just promoting this DNS over HTTPS. I'm promoting DNS encryption as a whole. So it's better to use HTTPS instead of HTTP, and it's better to use encrypted DNS instead of no encryption at all. So if this product probably doesn't fit your needs, or for some reason you don't like it, you just use any encryption that's provided. So there are many other options like DNS Script, DNS over TLS, and so on. But do use encryption. It's very important. So, well, are there any issues with this? Well, yeah, obviously the performance, it's a bit slower, as we have seen. And also about the internet part as well. So there are these SNI records being leaked when the certificates do the initial communication. So it's before the encryption phase. So some data can still be leaked, but it's not really connected that much to DNS over HTTPS, but the web as a whole. And, well, yeah, probably some pen testers and red teamers out there are just like, well, yeah, DNS encryption sounds cool. Yeah, I'm gonna use this. I'm gonna exploit it, and I'm gonna exfiltrate the information, and it's all gonna be fine. Well, obviously, since DNS over HTTPS is such a common standard, it is very well seen. For example, in streams like in things like Wireshark and so on, you can view the profile. Also, modern next-gen firewalls also support this. They show this traffic flow. And obviously, since it's HTTPS, basic proxy mechanisms also apply to it. So you can either have your local DNS over HTTPS server and then resolve if you need to do the public one, or you can just run normal DNS in your inner environment and then send out the request to a public DNS over HTTP resolver if the DNS name isn't local. So those are two options. Also, I would like to mention an important thing. So DNS over HTTPS is currently in IETF draft state. So it's not 100% confirmed yet. So it's still getting there. It's in number 14 now, so many additions have been made. And it will, I'm pretty confident that it will get there eventually. So yeah, these are a few references I used. And thank you.
Thank you very much. Are there any questions? Yes.
In your opinion, does the DNS over HTTPS put additional challenges in security monitoring for encrypted traffic, so in particular like HTTPS, let's say at the same firewalls and SIEM technologies?
Yeah, obviously it does put a little bit more challenges, but in my opinion at least, it's the easiest to implement from all the provided options currently. So that's my opinion. Well, obviously, if you have encryption, it takes some work, so you need to plan out smartly the deployment. But yeah, but I wouldn't really recommend it using right now in production. You have to wait maybe a year, maybe 2 for it to get 100% confirmed as a standard. So I'm just presenting the cool new technology that is available right now.
And one quick question. So the only browser what supports currently, let's say this state of art, is Firefox?
Yes, from the browser perspective, yes, but you can also find some code on GitHub where you can also set this up and you can make your normal DNS server send DNS over HTTPS requests from your server to the other server. So normal DNS coming in, so DNS over HTTPS in the outbound direction out of your network.
Thank you.
Are there any other questions? Yes.
Hi, hello. My name is Dana. I'm from the .lv registry. And I want to thank you for your presentation and drawing attention to this topic in general. And I have a question. What are your ideas and your attitude towards DNSSEC, DNS security extension? It kind of solves some of the problems. It doesn't solve all, as DNS over HTTPS. And in general, I have to say, like .lv domain names, they are getting more and more DNSSEC signed for the enterprise user perspective to secure their domain in general, so not to tamper the requesters. You had your example. But the awareness is rising, but not so quickly. And the second question, why so? Why do people only now pay attention to this like defect, or
so
I don't know how to
I would like to comment that this isn't really a new concept as the DNS encryption as a whole. So yeah, people are trying to do for quite a few years that. But about DNSSEC, so you need to implement it on your own. So each of the site providers needs to implement it on their own. So you can never be sure that the site you would like to visit, that it actually has DNSSEC enabled. And also, of course, it's recommended to also use DNSSEC on your domain also with this encryption. So it's more of so that your zone doesn't get transferred and so on.
And yeah, I agree to that. And what's about the second? Like, why do people only now pay more attention, like in general, to this topic? Because whenever we talk to enterprises and domains to secure their domains through DNSSEC or to use only the browsers that allow DNSSEC signed domain names to view, or warn them that this is not DNSSEC signed, it could be tampered, like, why so? Do you have any answer at all to that?
Well, obviously, I think the people in general are getting more privacy aware, security aware. So we are thinking more about these things as, how do I stay private on the internet? How do I hide my information? So it's like I mentioned the example with sealing your windows at the evening when you can see through them, for example, in like these big story buildings, so you can see everything that's happening in your neighbor. So you try to seal the window, and also people are understanding that on the internet it's basically the same thing. So everyone can see what you're doing. These on-path routers, they can easily just see the websites you're visiting, track your information, profile you, and use that. So I think people are getting smarter in this concept as well as privacy and security.
Thank you.
Any more questions? We still have time. Okay, I'll use the opportunity and ask one myself. You showed us the graphs where you measured the response times, which were a bit slower than straightforward, directly accessible DNS servers. But that relates to one query, probably. Has anybody measured the overall impact on browsing usage? Because, well, basically the web page consists of many elements, and those probably don't come from one source.
So what I didn't explain, that when you launch this initial query, the web address, the IP, and the name gets cached in your browser. So it's only the initial query that takes this time. Longer after that, it's just the web page is cached, and you can browse it seamlessly and quickly because it's already there in your temporary memory.
And the impact of the question was more about resources which are coming from different sources on the internet, which have different names. So that the impact you showed, it's the overall or it's the single source?
So it was from 25 users, the graph you mean, right? So that was from 25 users in total, so Firefox nightly users, which were monitored in this experiment. So that is quite a user base for this experiment.
But it shows. Okay, are there any other questions? Last chance. Okay, thank you very much for your interesting presentation.
Okay, thank you.